Happy Monday, everybody, and welcome back to another Planetarium live stream. And welcome back after a couple-week hiatus. We missed last week because of a special event at the Planetarium, but we're excited to be back for another Monday evening live stream. My name is Patrick Hess. I'm the Planetarium Specialist at Union Station, and I'm your host for this digital planetarium that we've been exploring for the past few months now. And I really appreciate all of you tuning in. We've been doing this ever since March, and it's changed and evolved over time, but I'm really excited that we can keep doing it and we can keep bringing you the stars from your home, whether you're in quarantine or whether you're just spending a Monday night with friends or family or just hanging out, you know, with your cat or something. I hope that this is bringing you some joy. If you're tuning in for the first time, welcome. We are live streaming every Monday night at 6 p.m. and we're covering a variety of topics, and we've covered a lot of topics in the past as well. I did want to bring that up, that don't forget you can check out all of our previous live streams, all of our other deep dive live streams, as well as our What's Up Star Tours and our Fan Fridays back from earlier in the year. We have a YouTube channel. Just search for Kansas City Planetarium and you'll find us there. You can find recordings of all of our previous streams where we've covered topics like taking deep dives into the outer planets like Jupiter and Saturn, learning about fantastical universes of fiction, how the Harry Potter universe works with astronomy. We've talked about awesome rocket launches like the SpaceX Dragon 2 launch that took American astronauts to space for the first time in a long time. And we've talked about other cool things like deep space objects and deep space probes. So definitely check those out. I also wanted to mention that we are reaching or getting close to a pretty awesome milestone. Either today or next Monday, we will be crossing over 150,000 views, which is really, really exciting. And I want to really just give another shout out to everybody who's supported us and supported me during these live streams, both the viewers at home and all of my awesome teammates at Union Station. So really exciting. And we've got a fun, exciting announcement about that. Next week, we're going to be celebrating that with a special edition live stream. We're going to try this out. It might be a lot to bite off, but I'm going to attempt to teach you 150 space facts next week. So we'll see how that goes. That's a lot, and I know I can get kind of long-winded. But I'd like you all to drop one of your favorite space facts in the comment section below during this video or afterwards, and I'll be sure to write that down and give you a shout out next week. If you have a space question, I'll incorporate that as well. And you're definitely not going to want to miss next week, because to celebrate 150,000 views, we will be giving away tickets, free tickets to the Planetarium. That's right, the Planetarium is open to the public, in case you didn't know. And we will be giving away free tickets to those who are tuning in live next week. So definitely don't want to miss that. We'll be back same place, same time, Monday night at 6 p.m. Again, free tickets to the Planetarium will be available to our live viewers there. And don't forget, like I said, the Planetarium is open to the public. So come see us, myself, as well as my other team members who are giving star tours and showing you all sorts of awesome shows, of course, with many safety considerations through the ongoing experiences that the world is sharing right now. Well, we're going to dive into this week's deep dive topic right off the bat, and that is all about Mars. So a really exciting thing happened relatively recently between the last time we streamed and this time on Thursday, the 30th of July. I believe that was the 30th. We launched the Perseverance rover to Mars. This is the latest NASA mission to explore Mars, and we're going to talk about Perseverance and other rovers like it, like the Curiosity rover, which has been exploring there. But first, I wanted to talk just a little bit about Mars and kind of do a deep dive into the red planet and our history of exploring the red planet. And we're going to start out here on the blue planet on Earth. We're back in Stellarium, a free piece of software you can explore the night sky with. And we've used this quite a bit to look at the evening skies here in Kansas City. But I wanted to point out that the red planet will be popping up a little bit later tonight. The red planet has been starting to rise earlier and earlier in the evening. And we are going to fast forward to hopefully catch it. Also, of course, we've got our lovely Kansas City horizon here, but I actually want to go ahead and change that up because it is kind of blocking our view. I did want to point out that we've got the planets Jupiter and Saturn visible in our evening sky up toward the south, those two bright points of light. But if you stay up late enough, they won't be the only planets you'll see. So right now, rising a little bit after 11:30, will be the red planet Mars. There it is right there. Over the course of the next few weeks, it'll be rising earlier and earlier. And if you come to the Arvin Gottlieb Planetarium in person in September to see our Fall Star Tour, we'll be taking a deep dive in 3D to the red planet. But since you're all tuned in now, I'll show you a little bit of the red planet today, don't worry. But that will be Mars rising there in the east. Again, this is right about midnight. It'll be up a little bit higher over the horizon, so you'll be able to see that. But over the course of the next few weeks, it'll start rising earlier and earlier. And then come September, you'll be able to see it in the early evening. And it'll shine as that bright red point of light. And remember, you can tell it's a planet because planets do not twinkle, whereas the stars twinkle in our night sky. But let's talk about Mars. And I want to switch things up, actually, back to another piece of software we have called Space Engine. And Space Engine is a 3D simulation of the entire universe, of course including the red planet Mars. Now this is a very advanced simulation, so it's simulating the effects of the atmosphere of Mars, reflecting light, so that's why it looks a little pale orange right here. Not as exaggerated as you might see in photographs or in books. But this is what you would see with the human eye if you were in a spaceship around Mars there. So let's just kind of talk about Mars briefly in general. So Mars is a very different planet from the Earth in a lot of ways, and it's a similar planet to Earth in some ways. It's about half as wide as the Earth, quite a bit smaller in mass, but about half the diameter. So if there were two balls rolling around on the ground, Mars would be half as tall as the Earth. And it's dominated by this red surface, this pale red surface. Now, Mars is mostly covered in iron oxide. We have iron oxide here on Earth. We call it rust. So Mars is basically a big ball of rust. And it's basically a giant desert planet, but not like most of the deserts you'd think of here on Earth. It is a very dry world, but it's very cold. It has a very, very thin atmosphere, which barely traps any heat, unlike the Earth's thicker atmosphere, which traps a lot of heat, and that's why it's nice and warm in most places here on Earth. So now Mars today is covered in rusty, dusty, nothing basically. It's just a huge desert planet. But beneath all that dust, hiding underneath the surface, there are quite a few scars of a former livelier existence. I don't want to say life because we don't know if there's life on Mars, but let's just say Mars's past was a little bit more exciting than it is today, because billions of years ago, Mars was actually a lot closer to Earth. It was very similar to Earth. It had a thicker atmosphere, about as thick as the Earth's today, and it also had oceans of water. So here is Universe Sandbox, which is a fun program that lets you simulate different physical aspects of the universe. So you can do physics simulations. We've used this a couple times to smash planets together, which is pretty fun. But I'm using this today to simulate what Mars would be like if it was covered in water, and it might look something like this. Now, did Mars have life in it back then? We don't know, but we do know that Mars had water, and we'll go over why we know that today. Now let's talk a little bit about the history of our understanding of Mars. Now this has evolved a lot over the past, and we've only been able to see planets up close, relatively up close, since telescopes were invented back in the 1600s, around that period of time. And over the course of centuries following that, different people looked at these planets in closer detail. And when they looked at these planets in closer detail, again, not with as much detail as we saw today, but early astronomers who looked at Mars imagined seeing sort of these long sort of lines across the surface of Mars. And these early 19th century astronomers, they mostly thought that Mars was covered in an intricate system of canals and waterways. And thinking of Mars in this way ignited the imagination of a lot of writers of that day. You know, we have writers like H.G. Wells, and he was inspired by these early imaginations of Mars in his War of the Worlds story. And there are other writers in the 19th and 20th century. Really famously, a lot of people don't realize this, but C.S. Lewis actually wrote a space trilogy. He's mostly famous for the Chronicles of Narnia, of course, but there's a really great space trilogy series, and this is one of my actually personal favorite science fiction stories. The first novel is called Out of the Silent Planet, and it involves an American astronaut, or I'm not sure American, but a human astronaut exploring Mars, and his imagination of Mars was covered in life and water and all sorts of things. So yeah, check that out, especially if there are Chronicles of Narnia fans. He did write a whole science fiction novel, which is kind of cool. A whole series, in fact. And then there's Edgar Rice Burroughs, who wrote his Mars series. He called Mars Barsoom, and the main character name was John Carter. There was a movie that came out, Hollywood movie, a couple years ago that was a little bit of an iffy adaptation, but it had some fun parts. This imagined a Civil War soldier getting transported to Mars and then participating in these huge Mars battles of political intrigue and all sorts of things like that. But let's fast forward to our modern exploration of Mars. And I've got a graphic here somewhere that shows us a little bit of a timeline. This is from NASA. NASA has a whole website about Mars. I think it's mars.nasa.gov. So be sure to check this out. But the first missions to Mars were the Mariner missions. And these were flybys. And Mariner 3 was lost, but Mariner 4 did collect the first photographs of the Martian surface up close. And I've got that photo here. So this was the first picture of Mars up close, taken by the Mariner 4 probe. The Mariner 9 probe actually made an orbit around Mars, and it took over 7,000 photographs, and it photographed over 80% of the Martian surface. And then there was the Viking program. So Viking 1 and 2 were the first orbiter, well, were the first landers on Mars. So the Viking 2 landed on Mars. And actually, it's kind of a funny story about that mission. They initially got a reading of biological activity on Mars when they were testing out measurements. But what they realized later is that they just hadn't decontaminated the rover very much. And so they were actually reading contaminated materials from the Earth. So sort of a false positive, but Viking did not find life on Mars. But these were back in the 60s and 70s. And then through a lot of the 80s, there really wasn't much of an exploration of Mars. Other than back in the 90s, we got back to exploring Mars. And then, oh, I forgot to show you all. Here's a photo, the first photo of the surface of Mars from the Viking 2 lander. I believe that's Viking 2. They also took the first color pictures of the surface of Mars. But again, through the 80s, there wasn't much exploration of Mars by the United States, but in the 90s, we got back to Mars in a big way. And we sent a number of probes there in the 90s and early 2000s. Don't forget, by the way, if you have any questions or comments or just want to shout out, be sure to chime in the comments. I'm not seeing a lot of people chiming in so far, so I just wanted to mention that. If you guys are watching and want to say hi, I love hearing all of your guys' shout outs, and if you have a question, be sure to ask as well, and I'll do my best to answer. So we'll do that live if you'd like. So back to our 90s probes. So in 1997, the Mars Pathfinder mission took place, and this was the Sojourner rover, which is this tiny little thing right down there. This was the first rover on the surface of Mars, and a lot of the things it was testing were mostly proofs of concept, so testing different systems that they might use for future rovers. But they did test some important things like the airbag landing system, which basically this thing just careened through the atmosphere and then put out airbags and just sort of bounced on the surface until landing, as well as automatic obstacle avoidance. Back in the 90s, they actually had a system of going around different obstacles. Some of the most famous Mars rovers, though, were definitely the rovers of the Mars Exploration Rover program, and these two rovers are named Spirit and Opportunity. And this is the prototype of those two rovers. They looked very similar, though, and that's them. Now, these missions were originally planned to only be 90 days long, but both Spirit and Opportunity way exceeded their original mission plans. These missions started in 2004. That's when they landed. And as I said, it was only supposed to last 90 days, but Spirit actually kept roving around till 2010, and then the Opportunity rover actually lasted until 2018, so actually very recently. And the Opportunity rover holds the record for the longest distance traveled on another world by any man-made object. Also, I wanted to kind of give sort of a sillier shout out, but there's a Twitter account that rates dogs, which is kind of fun. It's just called Dog Rates. But back when NASA announced that the Opportunity rover had lost power and we'd lost connection to it, I just wanted to point out that the Dog Rates account did give the Opportunity rover an honorary 15 out of 10 which seems like a worthy rating for a very, very good space rover. So good job, Opportunity. You really did some awesome science, and glad that we could have you for so long. So now Mars is really cool, and we've got a lot of images of Mars from the surface and from space, and we'll talk about a couple other missions exploring Mars. But Mars is really awesome because its surface is kind of like a big history book. Mars has pretty much no erosion on its surface except for some very light winds. So basically, different features on its surface have been there for billions of years, and we can make some really awesome discoveries just by looking at the surface, and we can see way back in time, way into Mars's history. So that's just one of the really awesome things about studying Mars. So I want to bring up something called Science on a Sphere. Now, Science on a Sphere is an exhibit. Oop, that's the wrong one. Science on a Sphere is an exhibit that we have actually at Science City. So you definitely want to come to check out Science City because there are a lot of awesome exhibits there. But one of the coolest exhibits, like I said, is called Science on a Sphere. And this is basically a 6-foot sphere that you can project all sorts of cool images onto. And on the Science on a Sphere website, you can actually see a lot of these data sets virtually. So definitely check that out. And that is, if you just Google search Science on a Sphere, it should pop up. But it is developed by NOAA, the National Oceanic and Atmospheric Administration. So they have a lot of land data sets about Earth, but they do have some space data sets as well. So you can pull up the data sets up here, and they are categorized. So we're going to pull up space. And I'm going to go all the way down. They've got a lot of data sets, thousands of data sets. But I want to show you all the Mars topography, and we can view an interactive sphere here. And this shows us a topographical map of Mars. The red color are the higher elevations, the mountains, and the bluer colors are the valleys and plains. So there are a couple really awesome features. There's this a huge red area here, the very tall mountainy area called Tharsis. It's much higher than many other regions, and it has a lot of extinct volcanoes covering it, including the one nearby, Olympus Mons. This is the tallest volcano in our solar system. Rises above the Martian surface over 17 miles. That's tall enough that it actually pokes out above most of Mars's very thin atmosphere. So the next time you are all on Mars and are looking for some mountain climbing to do, I would recommend checking out Olympus Mons. I hear the views at the top will take your breath away. So, assuming that you're all just roaring with laughter after that amazing joke, let's move on here. We've got right next to Tharsis the Valles Marineris Gorge, a gigantic canyon, also called the Mariner Valley. This canyon is over 2,500 miles long. That's compared to Earth's Grand Canyon, which is about 80 miles long. And this is also about a 5-mile deep canyon. So pretty awesome. A lot of other cool things. Let's circle back around here. Look at this really deep crater here. This is the Hess impact basin. The height from the crater rim to the crater floor is over 6 miles. So you could put Mount Everest in the middle of this crater, and then you could look down on Mount Everest's summit. That's how deep it is. And then this area around the Hess basin is called Noachis Terra, which is kind of means Noah's Earth. This is the oldest surviving terrain on Mars. So this region right around here is a region that scientists are very interested in studying because this area here contains geologic formations dating back billions of years into Mars's past. So let's talk about another probe. Let's talk about the Mars Reconnaissance Orbiter. This orbiter reached Mars in the early 2000s, and it has been photographing Mars's surface from orbit, and it has been one of the most productive missions. I believe it holds the record for most images taken by a single probe, and we still are getting new pictures from the Mars Reconnaissance Orbiter. But its main mission was to photograph the surface from orbit, and it's taken a lot of awesome pictures, and we don't have time to look at all the cool pictures, but I do want to show you something really cool here. One photo it took near the poles. Go back to our slide here. Here's a little animation showing a series of photos taken from close to the poles. And this is... Oh, you guys can't see this. Let's go back over here. There we go. All right, so now we're seeing it. So this is interesting. So these are a series of photographs taken by the Mars Reconnaissance Orbiter. And if you ask somebody, if you told them this is a picture of Earth, they might say, oh, that's water flowing down from some maybe cracks in the surface. Well, we don't know exactly if this is water. Some scientists think that it's a very salty, briny water that flows very slowly. Other scientists think that it's just dust that's sort of trailing down these slopes. But there's definitely some activity happening on the surface that could be flows of liquid water. And another photograph the Mars Reconnaissance Orbiter took is this. Now, this was from inside the Hess Basin, I believe, and using some spectrometry that the Mars Reconnaissance Orbiter has, it's able to determine what these different geologic formations are made of very broadly. And what we're seeing here are mineral deposits. Now, in studying the composition of these mineral deposits found on Mars, we found that these mineral deposits are incredibly similar to the same minerals found in hydrothermal vents at the bottom of Earth's oceans. And we also know that Mars was covered in liquid water in its very, very distant past. So, and we'll talk about why a little bit later. But so again, there are a lot of different features on Mars that make it seem like, you know, the conditions were right for Mars to have definitely have had water billions of years in its past. But could there be life? You know, a lot of scientists think that life may have began around areas like hydrothermal vents. There's a lot of life that teems down in those really warm pockets of the ocean. So, you know, who knows? It's pretty cool knowing that Mars had hydrothermal vents, though, in its distant past. Now, what happened to the water? If there was water there, well, where did it go? Well, let's continue and talk a little bit more about Mars's distant past. Now, the solar system went through a period about 3.8 billion years ago called the Late Heavy Bombardment. And we know this because when scientists started studying the lunar rocks that the Apollo astronauts brought back to Earth, we were able to measure the age of most of the craters on the moon, and we figured out that the vast majority of the craters on the moon, as well as many craters on Mars, came all around the same time period. There was a period of sort of peak crater formation during the early solar system about 3.8 billion years ago. We call this the Late Heavy Bombardment. Now, we've done some computer models, and we kind of think that Neptune is the culprit. We think that when Neptune was forming, it was kind of moving outwards towards an area of the solar system called the Kuiper Belt. And when it moved out there, it messed with the gravitational orbits of these objects in the Kuiper Belt and sent some of them back into the inner solar system. And that could have been what created the Late Heavy Bombardment. At any rate, we know that the inner solar system for a period of a few hundred million years was bombarded with tons and tons of rock. They estimate 53 tons of rock fell on every square meter of Mars. And it was, you know, pretty violent time. Over a third of the planet's surface was completely destroyed and changed. Now, after the Late Heavy Bombardment, the geology and the climate of Mars changed quite a bit. The water all over the planet froze, and volcanoes became extremely active. This caused some really violent glacial melting periods, which caused huge floods and some of the biggest waterfalls in our solar system's history. This waterfall is from an area called the Ekus Chasma. This waterfall would have been 2.5 miles long. And we can see evidence of these waterfalls still etched into the surface of Mars. And this is a photo taken by the Mars Reconnaissance Orbiter. We're not totally sure why the temperature changed on Mars that much, but most scientists think that it was mostly driven by the geology of what was happening below the surface of Mars, which we'll talk about in a minute. But I want to talk about another probe, the MAVEN probe. And let's go back to our timeline here. So MAVEN is pretty recent. This was actually 2013, arriving at Mars in 2014. This is actually one of the most recent missions to Mars, even after Curiosity. But I want to bring it up now because its main mission, this is another orbiter, its main mission was to study Mars's climate and figure out what caused this dramatic climate change. And, you know, a lot of people ask about, you know, well, why is NASA sending all these probes to distant planets? You know, what's it going to do for us back here on Earth? Well, MAVEN is a great example of this because, as I said, this probe was studying why the climate drastically changed on Mars. Well, if the climate is changing on Earth, then it could be helpful to learn why Mars has climate changed so much in the distant past. That could give us insights into why the climate is changing on Earth. And maybe it could give us insights into how to prevent too much of a bad climate change. So just a little info for you there about why, one of the many reasons why we are studying other planets. So the MAVEN probe is in an elliptical orbit, so it does these close passes of Mars, getting really, really close to the surface of Mars and then flying back out into space. And it kind of skims through the atmosphere to sort of measure the gases in the atmosphere of Mars. And when MAVEN did this, it found that the gas atmosphere of Mars is actually rapidly escaping out into space at quite a scary rate. And so this is kind of one of the main reasons why we think the temperatures changed so much on Mars. Remember, Mars's surface was likely, its atmospheric pressure was similar to Earth, and it likely had average temperatures of around the 70s. So honestly, if you were on Mars about 3.5 billion years ago, you could have been hanging out on the surface with just a oxygen mask, because there wasn't much oxygen in the atmosphere. But it's way, way colder today, and temperatures reach far below zero on the surface. And that's because its atmosphere is so much thinner today, because so much of it is escaping into space. Now, why isn't Earth's atmosphere escaping into space? Well, a lot of this is due to our magnetic field protecting us. So let me pull up. Do I still have it? I think I do. Yeah. So here's NASA has a lot of awesome websites, let me tell you, and they have this visualization studio where they just visualize a lot of different scientific data sets. And this particular page helps us to visualize the magnetic field of Earth. Now, below Earth's surface is a molten core of liquid rock. And this rock is churning around. As it heats, it moves upwards, but as the Earth rotates, it kind of spirals around. And this movement creates what's called a dynamo, which creates a magnetic field. And is it going to... Oh, there it is. Cool. So this is a really awesome animation showing us this magnetic field. Now, this magnetic field protects the Earth from solar radiation, from particles escaping from the sun, and this is also why the Earth has the northern lights. As you can see, the magnetic fields are centered on the northern hemispheres here, near the poles, and as these particles get trapped in the magnetic field, some of them reach the Earth's atmosphere, causing the northern lights up there. Now, Mars, as I said before, is much smaller than Earth. It has about half the diameter of Earth. So we think that Mars's dynamo core stopped producing this magnetic field a long, long time ago, far longer ago than the Earth's. And this is likely why Mars no longer has a magnetic field and is losing its atmosphere, because it doesn't have this magnetic field to protect it from solar radiation stripping away the particles in its atmosphere. So a really cool discovery made by the MAVEN probe, and you know, a little insight into what caused Mars to slowly die. You know, as it lost its atmosphere, the seas evaporated, it cooled down, it got really cold, and you know, all that water is no longer there. Well, what about why do we know that there was water there? Have we even found water on Mars? And you know, what leads us to these crazy ideas that billions of years ago Mars was an ocean planet? Well, most of that is due to the Curiosity rover. And I do want to check out, we've got a message, it looks like from Lee, I believe, saying, "Thank you for the show, Patrick." Well, thank you for tuning in. And they ask, is there a maximum/minimum life expectancy for probes? Do the longer probes operate on quote-unquote borrowed time? And that's a great question. So most of these probes, their missions are very short. As I mentioned, Spirit and Opportunity's prime mission was about 90 days long. We also did an entire live stream all about probes and rovers. I'd encourage you to check that out, because we talk a little bit more about that. But a lot of times, NASA engineers will sort of do lesser estimates for what their primary missions are. You know, they don't want to overpromise and underdeliver, obviously. They've got bosses too. But also just for scientific purposes, you don't want to plan parts of a mission very far into the mission when your rover runs out of fuel or an issue happens. So you want to try to get as much done early on before some of those bigger issues pop up. So that's a great question. Thank you so much for asking that, Lee. and some other people are chiming in. Oana, I'm glad you're finding this stream interesting. And Jordan's chiming in, saying, Maven, hashtag best orbiter. Maven's pretty cool. I like Maven, for sure. All right. Oh, and I do see that Dave is letting us know about a space fact, so thanks for letting us know. We'll definitely put that in our pocket and bring that back up next week. Remember, if you have a space fact you'd like to let us share and give you a shout out during our special 150,000 celebration live stream next week, be sure to post that in the comments, and we'll definitely write those down. All right, so let's talk about Curiosity. Curiosity is the most recent surface rover that we've sent to Mars, and it landed in 2012. And actually, I've got it right here with me. There it is, the Curiosity rover. This one happens to be made of Legos. This was a $2.5 billion mobile chemistry lab, and it had a lot of really awesome science. It had this robotic arm that had a lot of drills and scoops and capture devices to pick up samples and then deposit them in an area on its back that had some chemistry lab equipment. It had this camera up here, which actually also housed a laser, which is able to shoot lasers at rocks to create the to make them spark a little bit, and then a camera to snap a picture of the spark, and then use spectrography to basically measure the wavelengths that are coming from that spark to determine what that material is made of. It has 6 legs that are on these really cool articulating an articulating system, and this is how it works in the real probe on Mars. Pretty cool that they have this on Legos. But basically, the way that the NASA engineers designed this is that no matter what terrain this probe is on, all 6 wheels will always be on the surface. So if it's on a really crazy rocky terrain, no matter what, it'll always have all 6 wheels there, and it'll always be able to rove around. Now, Curiosity has made a lot of really awesome discoveries. One of its very early discoveries is a photograph taken of some rocks on the surface of Mars by Curiosity. And these rocks appear to be very rounded and smooth, and we think most likely smoothed by flowing water, just like pebbles in a creek bed. So really cool to think that this could have been a creek billions of years ago on the surface of Mars. And also that those instruments measuring the chemistry of the surface of Mars, when Curiosity first started measuring the surface soil and dust on the surface of Mars, it found that today about 2% of all Martian soil is still made of water. So there is currently water on Mars, and that is one of the main reasons, along with all these other bits of evidence that point us to the conclusion that Mars likely was covered in water in its distant past. Now, Curiosity landed in the summer of 2012, but on July 30th, just a couple weeks ago, Curiosity's, I guess you could say, big sister, Perseverance, launched. And this launch happened flawlessly, and this rocket is now on its way to the Red Planet. Its scheduled arrival is February 18th, 2021, so mark your calendars. And if we're still live streaming by then, we will definitely do a live stream all about the Perseverance landing. But one of the coolest things about Perseverance is how it's going to land. And Perseverance landing system is very similar to the Curiosity's landing system. And the scientists who created this landing system have very affectionately called it the 7 minutes of terror. And so I've got so many windows on my screen. I'm just trying to find the one that controls this. Okay, there we go. So I want to show you guys a video, and we're going to talk through how this probe is going to land. So this is a video showing how the Curiosity rover landed, but again, the Perseverance landing system is based on the same platform. So on February 18th, Perseverance will be going through its own 7 minutes of terror. So we're going to go back over here to this video, and this video is provided by NASA and the Jet Propulsion Laboratory, where both of the rovers were created. Yeah, so let's go ahead and start this up. So So again, it takes months and months for this rover to get, or this probe to get to Mars. But once it reaches the upper atmosphere, it only takes 7 minutes to get from the edge of the atmosphere to the surface of Mars. Now, because Mars is so distant from us, and because the way we communicate is by light waves, electromagnetic waves, radio waves in this case, it takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far away Mars is from us. So, when scientists first get the word that Perseverance has touched down, or actually when scientists first get the word that Perseverance has reached the upper atmosphere, the vehicle has likely either touched down or has crashed down. So that's why they call it the 7 minutes of terror. So this period, the entry, descent, and landing, also known as EDL, is called the 7 minutes of terror. So this rover, this Perseverance spacecraft, is going to go from 13,000 miles per hour to 0 in perfect sequence, perfect choreography, and perfect timing. And all those things have to happen for this mission to succeed. And the computer has to do it all by itself, because with that huge delay, we can't, remote control this rover as it's landing. So as soon as the probe slams into the atmosphere, it develops so much aerodynamic drag that the heat shield heats up and glows like the surface of the sun, over 1,600 degrees. Now, during the entry, the vehicle is not only slowing down violently through the atmosphere, but they're also guiding it. They're actually steering it like an airplane to try to land it in this really narrow space. They want to land it in just the right spot, This is one of the biggest challenges. And Mars, because it has a very thin atmosphere, it's extremely hard to slow down in the atmosphere. So got to be very careful about that. Now, at this point, they're still going 1,000 miles per hour. So at this point, they use a parachute. So this parachute is the largest and strongest supersonic parachute that has ever been built. And it's able to withstand 65,000 pounds of force, even though the parachute only weighs about 100 pounds itself. When it opens up, it's a neck-snapping 9 Gs. But at this point, the parachute is not the only thing that's going to be slowing it down. It only slows this down to about 200 miles per hour. And I want to pause here real quick. So the parachute can only slow down this descent to about 200 miles per hour, but that's not slow enough to land. So at this point, the parachute has to be cut off. And then we have to use rockets to do a controlled descent. So the rockets actually will lower this probe close to the ground. Now, also, when the rockets blow, they don't want to crash back into the parachute, so it has to steer away from the parachute really quick. So all these things are happening in tandem. The parachute's gliding down, the rockets launch, but the rockets got to get the probe away from the parachute. So it's really, really intense. And so it does this radical maneuver to divert out of the way, and it flies off to the side, and then it slows back down and stops at horizontal velocity and starts to hover there, okay? Now, at this point, they are going to be hovering very, very close to the surface, about 20 meters above the surface. But we can't get the rockets too close to the ground because it would cause a lot of dust. So the dust would upset all the instruments. It would block a lot of the instruments that are really important to help sort of guide the probe down and the rover down to the ground. So to prevent this damage to these instruments and damage to the rover from dust, what happens is the whole contraption hovers about 20 meters above the surface, and then the rover itself, Perseverance, is going to be lowered on a crane. So a sky crane on wires is going to lower. And again, this already happened. This is how Curiosity landed. This is crazy, right? But they designed this and it's already worked once. So it's going to lower Curiosity, or Perseverance in this case, down about 20 meters. And then the wheels will pop out and they'll make sure everything's working, and then it'll just very gracefully touch down, and then that descent module will fly off and then just crash somewhere else to get away from the landing site. So all of that happens in 7 minutes, and again, by the time the process starts, it will have already ended by the time the NASA scientists are watching this happen. So these 7 minutes of terror are going to be very intense on February 18th. But hopefully Perseverance will land successfully and we'll be able to get some science from it. So really, really cool animation there. Again, thanks to NASA for providing that one. So Perseverance is based on a very similar chassis to Curiosity. So it has a lot of similar systems, but there are some changes and some improvements Obviously, a lot of the instruments and computer programming will have improved just over the last 8 years since these two probes were developed, sort of together, but on different timelines. And then I can get out of the way here. But one difference is in the wheels. The Curiosity rover has actually had a lot of problems because its wheels have encountered a lot of damage. If you look at photos of the wheels of Curiosity, there are a lot of small holes and pockmarks in them. Luckily, Curiosity's fine. It's still roving around. But one thing we were able to do is we were able to see how Curiosity performed and then able to make some improvements to Curiosity's big sister, Perseverance. So hopefully the wheels will be a little more sturdy, a lot more color cameras, a heftier turret, which has a lot more scientific instruments. It will be able to actually collect rock core samples, which it won't be able to analyze, but it will be able to store them for hopefully future scientists to actually go there in person to collect those samples. Yeah, so it's got a lot of really awesome improvements. And one cool thing about both Curiosity and Perseverance is that they are nuclear powered. So this thing on the back of the rover is actually a nuclear power system that basically lets this rover operate at nighttime, so it doesn't need solar power. It's actually able to operate just based off of residual heat coming from radioactive decay of an element there in that reactor. So very, very cool. Again, here's a comparison size-wise too. So both of these probes are about the size of a car and about as heavy. But you can see Perseverance is a little bit bigger, but basically based on the exact same chassis as Curiosity. And one of the other really cool things about Perseverance is it's not the only mobile probe going to Mars. NASA is also sending an experimental aircraft. I think it's called Ingenuity, I believe. And this is actually going to be a helicopter that they plan on trying to fly on Mars. This will be the first aircraft on another planet. Hopefully it'll all work okay. At least it'll work one time probably. But hopefully they'll be able to land it and continue using it. But pretty cool. We're sending a helicopter to Mars. Should be really awesome. So that is an exciting update about our solar system exploration. Again, that mission is underway. We launched on July 30th, just a few days ago. And on February 18th, hopefully those 7 minutes of terror will end just as well as Curiosity did back in 2012. But we'll have to wait a few more months to find out. And we are going to start wrapping things up. And I noticed we've got one more question from Heather asking, is it true that this new probe will be testing the atmosphere to see if it can be made breathable for humans? So Perseverance will definitely have a lot of instruments on it to measure all sorts of things on the surface of Mars. And I'm not 100% sure if it has any instruments to measure the atmosphere of Mars. But most likely it has some basic instruments just to take some basic readings there. As for whether or not the atmosphere could be made breathable, some scientists have some theories about how that could happen. But there would be a lot of things we'd have to change. Breathable is one thing. It'd be a little more attainable to make the atmosphere thick enough that we could be exposed without a spacesuit. Right now we need a pressure suit because the atmosphere is so thin. Our bodies are not adapted to that amount of air pressure. But to put enough oxygen in the atmosphere and remove other gases to make it breathable is probably a lot less likely without huge advances in our understanding of science. But again, there are some scientists who think it could be terraformed enough over the course of a few human lifetimes that perhaps it could be warm enough and the pressures in the atmosphere could be comfortable enough that we could be out there with maybe just a mask. So that may happen, but you know, it might be a couple decades before we get there. Fingers crossed, though, that'd be great if we got there a little bit sooner. Just saw we got another question from Bobby asking, how do we have photos of waterfalls if they were there billions of years ago? Well, those weren't real photos. That was a artistic visualization. But we do have photos of the area affected by the waterfalls. So this is a photo of the area around the waterfalls, and a lot of these features match similar water erosion patterns that we see here on Earth. So again, combining these photographs of Mars and surface samples that we've taken of Mars and many other scientific data points, we now have a lot of evidence pointing to the theory that Mars had water in its distant past being true. Again, we'll never know unless we can go back in time, but our science is pointing us in that direction for sure. So I believe that was our last question. So we are going to go ahead and start wrapping things up. Thanks again so much, guys, for tuning in for our live stream. Hope you enjoyed our deep dive into our history exploring Mars. I definitely did. And remember, you can watch all of our previous live streams on our YouTube channel. Just go to YouTube and look for the KC Planetarium, and you'll find us there. And don't forget to tune in next week, because we will be celebrating 150,000 views. It's been quite a journey doing this ever since we started working from home in March, and then continuing after the planetarium opened back to the public. We're still live streaming, and we still will be every Monday as long as you guys are watching. So thanks for tuning in. Thanks for asking us questions. If you're watching this not live, feel free to jump in the comments anyway and ask a question or post your favorite space fact. Remember, we will feature that next week, and we will reread the comments next week to make sure we don't miss anybody who's watching after the fact. But to all of you watching live right now, thank you again so much for tuning in. Once again, I've been Patrick Hess, your planetarium specialist. I'll see you next week on Monday at 6 p.m. for our next live stream celebrating 150,000 views. Or I will see you at the planetarium in person for one of our live star tours. Thank you guys again for tuning in. I hope you have a great rest of your week, and we'll see you next time.